Welcome to the how-to video for the op-amp homework. Okay, let's do our first problem, and this is an inverting amplifier because our input voltage goes into our inverting side. So let's go ahead and figure out the gain. So our voltage gain equals RF over Rn, and it's going to be a minus. There is no minus gain, but I usually put the minus there, so remember that our output is going to be a negative because it's an inverting amplifier. So 7 divided by 3 equals 2.33. So our output voltage equals our input voltage times our gain. And we're always going to have a minus voltage because it's inverting. So let's multiply that times our input voltage, 60-second EE minus 3. Let's try that again. So 7 divided by 3 times 60 second EE minus 3 comes out to 0.14 volts, or 140 millivolts minus. Okay, this is a non-inverting amplifier because it is going into our non-inverting input, and its formula for gain, A small v, equals RF over Rn plus 1. So we have 20k over 5k plus 1 equals 5. So we have a gain of 5, and 5 times 150 millivolts equals, so let's go ahead and use the calculator here. So we have 5 times 150 second EE minus 3, and we come up with 0.75 volts, or 750 millivolts, and it is plus because it is a non-inverting. This is a summing amplifier where we're going to look at each of these separately and we're going to sum them up. So the first thing is going to be our gain. So we have 10k over 5k times 150 millivolts, and then we're going to have 10k divided by 3k times 80 millivolts, and we're going to add these as we go. So we got 10k over 2k times 50 millivolts. So this first one, and they're all going to be minus, so we have 2 times 150 is 300 millivolts minus, and then we have 10 divided by 3 times 80, we're going to have 266 millivolts minus, and our last one is going to be 5 times 50, or 250 millivolts minus. So let's add them all up. And I have 816 millivolts. Here's an op-amp with no feedback resistor, so it is a unity gain op-amp, or a buffer, and our gain is going to be simply 1. Okay, this is an inverting amplifier again because it is going into our inverting input, sorry. And our formula is AV equals RF over Rn. And if we redo that one looking for RF equals AV times Rn. And it's going to be 4 times 3K or 12K ohms. Here we have a non-inverting op-amp. Because it's going to non-inverting, so our formula is voltage gain equals RF over Rn plus 1. And we're looking for RF, so we're going to have AV divided by, multiplied by Rn, sorry, and minus 1. So we have a gain of 3 times 3K minus 1 equals 8. Okay, this is a difference amplifier, and if you notice, our resistors are the same on both sides of the input, and what we do is we take the difference between the two input voltages. So we have a positive 10 because it's going into the non-inverting, and we're going to subtract the 5 volts from the inverting, and we're going to multiply it by the gain of one of these sets, RF over Rn. So we have 5 volts times 10 divided by 5. And we should end up with 10 volts positive. Here we have an inverting amplifier. We're looking at what we call the virtual ground. The inputs of our op-amp are going to be equivalent at our inputs. Since this one is held at ground, this one's going to be held at ground, which is 0 volts. So that point A is 0 volts. And let's figure out our gain. So we have RF over Rn. And we have 33K ohms divided by 11K ohms equals 3 is our gain. So we have 3 times our input voltage, which would be 20 millivolts, which equals 60 millivolts, and it's minus because it's an inverting amplifier. Okay, here we're looking at a non-inverting input because our voltage goes into our non-inverting input, and it's asking for A. And again, since we do our voltages are locked into our inputs, this is going to be 200 and this is going to be 200 millivolts. So A is going to be 200 millivolts. And this is an inverting amplifier, non-inverting. So our formula is going to be AV RF over Rn plus 1. So we have 10 divided by 2 plus 1 equals gain of 6. So 6 times our input voltage is going to be 1.2 volts positive. What we have here is an op-amp acting as a comparator. And the way comparators work is the larger voltage goes into which input will drive it to that rail. So -2 is actually greater than -4. A tricky question here. So this is actually the greater one. So it's going into the positive rail. So it's going to go to the positive rail, which is 12 volts. We're going to say 90%, 0.9. And that would be simply just the positive rail.